Good morning, students. Today's lesson, Unit 10, Types of Chemical Reactions. Unit 10, Types of Chemical Reactions. Today's topic, Learning Objectives, Rate of Chemical Reaction, Factors influencing the rate of the chemical reaction, Nature of the reactants, Concentration of the reactants, Temperature, Pressure, Catalyst, and surface area of the reactants. How the factors of nature of the reactants, concentration of the reactants, temperature, pressure, catalyst, and surface area of the reactants are influencing the rate of the chemical reactions. First, nature of the reactants. The nature of the reactant is also important in a chemical reactions. The reaction of sodium with hydrochloric acid is faster than that with acetic acid. The reaction with the sodium and hydrochloric acid is very faster. At the same time, the sodium with acetic acid is slow reaction. The reaction of sodium with hydrochloric acid is faster than that with acetic acid. Do you know why? What is the reason? Hydrochloric acid is a stronger acid than acetic acid. This is the important point. Hydrochloric acid is a stronger acid than acetic acid and thus more reactive. So the nature of the reactants influence the reaction rate. The chemical reaction in the chemical reactions, hydrochloric acid is stronger acid than acetic acid. So the reaction rate is fast in sodium plus hydrochloric acid reaction. See the reaction 2Na plus 2HCl gives 2NaCl plus H2. So more amount of hydrogen gas is liberated in this reaction. So this is the fast reaction. From this, nature of the reactant also increase the chemical reaction, that is confirmed. Next, this is a reaction between sodium and hydrochloric acid. This is a reaction between sodium and acetic acid. Sodium and hydrochloric acid. Hydrochloric acid is vigorous. So the reaction rate is very fast. Here, reaction between sodium and acetic acid, the rate of the reaction is very slow. See the second reaction, sodium plus hydrochloric acid to form sodium chloride and hydrogen gas. More amount of hydrogen gas is liberated at the fraction of time. So this is a fast reaction. Sodium reacted with the acetic acid to form sodium acetate and hydrogen gas. So less amount of hydrogen gas is only liberated. This is slow reaction. So the reaction between sodium and hydrochloric acid is fast reaction. Reaction between sodium and acetic acid is very slow. From these two examples, we understand that the reactants also influence the rate of the chemical reactions. Next, concentration of the reactants. How the concentration is increased or decreased the chemical reactions. Changing the amount of the reactants also increases the reaction rate. The amount of the substance present in a certain volume of the solution is called concentration. This is the important point. The amount of the substance present in a certain volume of the solution is called concentration. More the concentration, more particles per volume exist in it and hence faster the reaction. Example, granulated zinc reacts faster with 2M. 2M means 2 molarity. 2 molarity hydrochloric acid than 1 molarity hydrochloric acid. The molarity is increased, the concentration is also increased. If the concentration is increased, rate of the reaction is also increased. So the 2 molarity hydrochloric acid is reacted very fast with granulated zinc. A reaction, magnesium plus hydrochloric acid 1 molarity, magnesium plus 2 molarity of hydrochloric acid. 1 molarity, 1 m means 1 molarity, 2 m means 2 molarity. So the product is MgCl2, magnesium chloride and hydrogen gas is liberated. So 1 molarity of the hydrochloric acid is take part in this reaction. So the reaction rate is slow. At the same time, 2 molarity of hydrochloric acid is a take part in this reaction. The reaction rate is fast. More amount of hydrogen gas is liberated. The product is also same. Magnesium chloride, here also magnesium chloride. The rate of the reaction is slow in the first reaction. The rate of the reaction is very fast in the second reaction. So the concentration is also increase the rate of the chemical reaction. Consider the reaction between zinc and hydrochloric acid. Zinc plus HCl. Zn plus 2HCl gives ZnCl2 plus H2 acid particles and zinc. The reaction between zinc and acid. 1 molarity hydrochloric acid, 2 molarity hydrochloric acid. There are more particles of acid per unit volume in the 2 molarity acid than there are in the 1 molarity acid. So there will be more collisions between the acid and zinc particles in the stronger acid, giving a fast reaction. The higher concentration, so the reaction is also fast. This is the reaction between zinc and hydrochloric acid. Next, how the temperature is increase the rate of the chemical reaction. Most of the reactions go faster at high temperature. Most of the reactions go faster at high temperature because adding heat to the reactants provides energy to break more bonds and thus speed up the reaction. Calcium carbonate reacts slowly with hydrochloric acid at room temperature. Calcium carbonate reacts slowly with hydrochloric acid at room temperature. When the reaction mixture is heated, the reaction rate is increased. In the room temperature, the rate of the reaction is normal. At the same time, when the reaction mixture is heated, the rate of the reaction is also increased. From this, we understand that the temperature is also increase the rate of the chemical reactions. Example, calcium carbonate CaCO3 reacted with the 2HCl. The first and in the first and second reaction, the reactants also same. Calcium carbonate, calcium carbonate. Hydrochloric acid, hydrochloric acid. Two reactants also same. But one is slow reaction, another one is fast reaction. How it is possible? So calcium carbonate react with hydrochloric acid in the room temperature. So a less amount of carbon dioxide is liberated. The product is CaCl2, calcium chloride. Carbon dioxide is also formed. Then what is the product? This is slow reaction. So carbon dioxide gas liberated slowly. So this is slow reaction. At the same time, the reaction between calcium carbonate and hydrochloric acid is taken in a test tube and heated. So the symbol indicates a heating. Okay, calcium carbonate is reacted with hydrochloric acid and it is heated to form the same product, calcium chloride. The first reaction, carbon dioxide is evolved. Here also carbon dioxide is evolved. But water is a byproduct. Here also water is a byproduct. The product also same in these two reaction. But the first is the slow reaction. Second is the fast reaction. So heat temperature is also increase the rate of the reaction. Food kept at room temperature spoils faster than that kept in the refrigerator. In the refrigerator, the temperature is lower than the room temperature and hence the reaction rate is less. This is the reason. This is an important question. Food kept at room temperature spoils faster than that kept in the refrigerator. In the refrigerator, the temperature is lower than the room temperature and hence the reaction rate is also less. Then next, pressure. If the reactants are gases, if the reactants are gases, increasing their pressure increases the reaction rate. This is because on increasing the pressure, the reacting particles come closer and collide frequently. So the pressure is also increase the rate of the chemical reactions. Reaction rates. Pressure. Pressure affects the rate of the reaction, especially when at least one reactant is a gas. When you increase the pressure, the molecules have less space in which they can move quickly, move randomly. This increases the concentration of molecules, which increases the number of collisions. When you decrease the pressure, molecules don't hit each other as often. The lower pressure decreases the rate of the reaction. So less pressure is more pressure. So the pressure is increased, rate of the reaction is also increased. Next, how the catalyst is a take part in a chemical reaction. How the catalyst is a take part in the chemical reaction. A catalyst is a substance which increases the reaction rate without being consumed in the reaction. In certain reactions, adding a substance as catalyst, it speeds up the chemical reaction. On heating, example, on heating potassium chlorate, it decomposes into potassium chloride and oxygen gas, but at a slower rate. The rate of the reaction is slow. If a manganese dioxide is added with these two reactants, it increases the reaction rate. Here, manganese dioxide acts as the catalyst. After the addition of manganese dioxide, that is catalyst, the rate of the reaction is also increased. 2KCl3, potassium chlorate, in the normal temperature at room temperature, the reaction is slow. The less amount of oxygen gas is liberated. So 2KCl, potassium chlorate, in the room temperature to form potassium chloride and oxygen gas is liberated. The rate of the reaction is slow. Here, the same reactant, potassium chlorate, is heated. The presence of manganese dioxide. Here, manganese dioxide acts as a catalyst. After the addition of manganese dioxide with potassium chloride, the rate of the reaction is also increased. More amount of oxygen gas is liberated. The product also same potassium chloride and oxygen gas is liberated. So this is a fast reaction. This is the reaction of catalyst. For example, on heating potassium chloride, it decomposes into potassium chloride and oxygen gas. But at a slower rate, if manganese dioxide is added, this is after the addition of manganese dioxide, the reaction rate is also increased. This is at room temperature and without the catalyst. Here, after the addition of catalyst, that is manganese dioxide, the rate of the reaction is also increased. So, catalyst also increase the rate of the chemical reaction. And then, surface area of the reactants. How the surface area of the reactants involved in the chemical reaction. Surface area. When solid reactants are involved in a reaction. When solid reactants are involved in a reaction, their powdered form reacts more readily. For example, powdered calcium carbonate reacts more readily with hydrochloric acid than marble chips. For example, powdered calcium carbonate reacts more readily with hydrochloric acid than marble chips because powdering of the reactants increases the surface area and more energy is available on collisions of the reactant particles. So this is a low surface area, high surface area. Okay. So the powdering of the reactants increases the surface area and more energy is available on collision of the reactant particles. So surface area is increased, rate of the reaction also increased. The example, calcium carbonate, this is a powder form of calcium carbonate reacted with hydrochloric acid to form calcium chloride, CaCl2, carbon dioxide and water. Compare these two reactants to chemical reactions. This is calcium carbonate. This is also calcium carbonate. Hydrochloric acid, hydrochloric acid. The product calcium chloride and calcium chloride, carbon dioxide and carbon dioxide, water. So both the reactants and the product also the same. First, but the first reaction is very fast. Second reaction is slow. Reason, this is a powder form of calcium carbonate. The reactant in the taken in the first test tube is a powder form of calcium carbonate. This is marble, solid form of calcium carbonate. So if it's a powder form, so surface area is increased. So rate of the reaction also increase in the first reaction. Because the rate of the reaction is increased in the powder form because powdering of the reactants increases the surface area and more energy is available on collision of the reactant particles. So the reaction rate is increased. From these reactions, we understand nature of the reactants, concentration of the reactants, temperature, catalyst, pressure, and surface area of the reactants. These are also increase the rate of the chemical reactions. Thank you, students.